Welcome back to another explainer. Today we're popping the hood on something most of us use every single day, but honestly rarely think about. We're going to demystify the absolute miracle of engineering that is the car engine. We'll break down exactly how this incredible machine takes a tank of liquid fuel and transforms it into the explosive forward motion that gets us down the highway.
Here's our roadmap for today. Number 1, core components. Number 2, the 4-stroke cycle. Number 3, vital support systems. Number 4, petrol versus diesel. And number 5, 2-stroke and rotary alternatives. Let's get right into it.
Section 1. The engine's core components. Okay, meet the piston. Usually made from a super tough aluminum alloy, this is the absolute inner powerhouse of your engine. It sits perfectly snug inside the main body, which we call the cylinder block. And its sole job? To take the immense, violent pressure from fuel exploding and push that resulting force straight down. I mean, it is literally the frontline soldier taking the brunt of thousands of controlled explosions every single minute.
But here's the thing, just moving straight up and down is not going to spin your wheels, right? That is where the crankshaft comes in. There's a piece called the connecting rod that links the bottom of our piston directly to this crankshaft. So when that piston gets slammed downward, the connecting rod pushes on the crank, taking all that violent up and down energy and beautifully smoothing it out into a spinning, rotational motion.
Let's put this into perspective with something you probably see every time you drive. You know that dial on your dashboard labeled RPM? That's exactly what this is measuring. RPM stands for revolutions per minute. When you're driving and that dial reads 3,000, it means that heavy steel crankshaft is making 3,000 full, complete spins every 60 seconds. And to keep things from violently shaking apart, it uses heavy counterweights to balance out the pistons.
Now, for any of these explosions to actually happen in the first place, the engine has to breathe. Up at the very top, in the cylinder head, we've got our intake and exhaust valves, which are held shut by these really heavy springs. The intake valve opens up to let air and fuel in, and the exhaust valve opens to let the burned gas out. But there's a pretty ironic engineering problem here. Compressing those thick valve springs takes a ton of physical strength, so the engine actually has to rob a fraction of its own combustion power just to take its next breath.
Section 2. The 4-stroke cycle. So, we've got these incredible metal components sitting inside a cast iron block, but how do we actually orchestrate them to generate forward power? Like, how does the fuel physically become motion? Let's walk through it. Most modern car engines use what's called the Otto cycle, which breaks down into 4 specific strokes of the piston. First up is intake. The piston drops down, creates a vacuum, and literally sucks the air-fuel mixture right into the cylinder. Next is compression. The valve slams shut and the piston pushes back up, violently squeezing that mixture and skyrocketing its temperature and pressure. Then, the magic happens. The power stroke. A spark plug ignites that highly pressurized mix, and since the rapidly expanding gases have nowhere else to go, they fiercely shove the piston back down. Finally, the exhaust stroke. The piston comes back up one last time to push the leftover burned gases out the open exhaust valve. And the crazy takeaway here? Out of those 4 precise strokes, only one, the power stroke, actually generates energy to move the car. The other 3 are literally just resetting the stage.
Section 3. Vital engine support systems.
We've just been looking at a single cylinder, dealing with this blistering hot, violent process thousands of times a minute. But if we just left the engine on its own like that, it would literally melt itself into a block of scrap metal in seconds. It needs life support. First, lubrication. An oil pump constantly circulates oil from a sump at the bottom, creating a protective film between all those fast-moving parts to prevent catastrophic metal-on-metal friction. Then there's the cooling system, which pumps a mix of water and antifreeze through channels in the engine block to carry the intense heat away. On top of that, you have precise fuel injectors and air filters, making sure the exact right recipe of explosive mix is entering the engine. And finally, the exhaust system uses a catalytic converter to tirelessly scrub out toxic chemicals before they leave your tailpipe.
Section 4. Petrol versus diesel engines. Now that we've got a safely running engine, let's talk about the 2 main variations you'll actually see out on the road: petrol, or gas, and diesel. Both of these use that exact same 4-stroke cycle, but they handle the power stroke entirely differently. A petrol engine relies on a spark plug. It literally needs a perfectly timed electrical spark to ignite the fuel mix. But a diesel engine, it completely ditches the spark plug. Instead, during that compression stroke, a diesel engine squeezes the air so incredibly tight that it gets insanely hot. So hot, in fact, that the moment fuel is injected, it spontaneously erupts from the sheer heat of the compression alone. Pretty wild, right?
Section 5. Two-stroke and rotary alternatives.
It's amazing how one little change shifts the whole personality of an engine. But what if we completely threw out the traditional four-stroke rulebook to save weight or change the motion? Earlier, I mentioned those annoying, power-stealing valves at the top of the cylinder. Well, the two-stroke engine brilliantly solves that by just eliminating them completely. While a four-stroke engine clearly separates every single step, a two-stroke overlaps them. It's essentially the ultimate multitasker. By lumping intake, compression, power, and exhaust together, it squeezes way more action into a fraction of the time, all while shedding the heavy weight and friction of a complex valve system entirely.
But if you want to see the wildest internal combustion engine out there, we have to talk about the Wankel, or rotary engine. Invented back in 1951, this variation completely throws the traditional up-and-down piston right out the window. It still hits those four stages: intake, compression, combustion, exhaust, but it directly converts that pressure into a smooth, rotating motion right from the start. Think about this setup. Instead of a cylinder, the Wankel uses a triangular rotor that spins inside an oval-shaped housing. Because it's a triangle, it naturally sections off the chamber into separate moving areas. As it spins around a central gear, it sucks air in, squeezes it against the wall, takes the blast from the spark plug, and sweeps the exhaust right out the port. One single smooth rotation of this triangle is doing 3 separate actions at the exact same time. It's just a stunning piece of alternative engineering.
Whether we're talking about a classic four-stroke V8, a multitasking two-stroke, or a spinning rotary, it really all comes down to the sheer beauty of mechanical choreography. Just to give us a smooth ride to the grocery store, we're relying on a timing belt linking camshafts to crankshafts so valves open at the exact millisecond a spark plug fires. Oil and coolant are constantly flowing to fight off friction and heat. And pistons are literally taking turns firing in a super precise order just to keep the power delivery totally smooth. It's an intricate, violent, yet perfectly balanced dance.
Which leaves us with this final thought. We are quickly moving into an era where electric vehicles are massively simplifying our cars, swapping out thousands of these explosive, moving metal parts for a quiet battery and electric motors. So when we look back at a century of automotive history, which of these intricately, beautifully complex combustion designs will be remembered as humanity's ultimate mechanical marvel? Thank you so much for exploring the heartbeat of the engine with me today on this explainer. Keep asking questions, keep learning, and I'll catch you next time.